Okay, so here we have our first question from exercise 1.1. So we have to find the remainder of this cubic polynomial when we divide by x plus 2. So using the remainder theorem, we need to substitute in the opposite of the x plus 2, which is negative 2. So therefore, if we put in negative 2 into that polynomial expression, it will give us our remainder. So if we do that, apologies for the handwriting, and we sub in negative 2 wherever we see x, we should come up with negative 16 plus 12 plus 8 plus 1, which gives us a remainder of 5. So when we divide that cubic polynomial, we divide by x plus 2, we get a remainder of 5 using the remainder theorem. Okay, here we have question 2. Okay, now we're dividing, very much similar to question 1, we're dividing a quartic polynomial now by, again, a linear factor. Okay, so if you're not sure what you need to substitute in for the remainder theorem, just set that linear factor equal to 0 and solve for x. So therefore that will lead us to x equals a half. So we need to divide by, sorry, not divide by, we need to substitute the value of a half into that expression. So if we do that, p of a half equals, this is going to get a bit messy, but we'll see how we go with the fractions. Okay, minus 2, that's a 2. So a half to the power of 4 is 1 over 16 as the top. The numerator gets to the power of 4 and the denominator also gets the power of 4. That's 1/4, that's 3 over 2, and that's 2. So let's put that all together and simplify. That's 1 over 8 minus 2 over 8 plus 12 over 8 minus 16 over 8 if we employ a common denominator of 8. So if we subtract those, we're going to get 1 minus 2, which is negative 1, plus 12, which is 11, minus 16, which is negative 5. So if I haven't done anything silly, my remainder of this question is negative 5 over 8. Okay, so here with question 3, we've got a slight variation on how you do these problems. So in this particular question, we're looking for the unknowns a and b, the coefficients of the quadratic and the linear terms respectively. So they've given us two pieces of information. The first one being if we divide our quartic by x minus 1, we get a remainder of 2. And the second one is if we divide by x plus 1, we get a remainder of negative 6. So we're essentially going to have to work backwards here and sub in the values of 1 and negative 1 and create two simultaneous equations to solve for a and b. So in the first scenario here, if we sub in p of 1, it's telling us that if we actually sub in the value of 1, the remainder that we'll get is 2. And then the second piece of information says if we sub in negative 1, we get a remainder of negative 6. So we now have to go about subbing these values in and creating two equations in terms of a and b, and therefore we can solve. So let's go about and doing this for equation 1. So if we sub in 1, we're going to get 1 plus a plus b minus 2 equals 2. So rearranging that, we're going to get a plus b equals, if I take that across, that gives me 3, so there's equation 1. And the second equation, if I sub in negative 1, I'm going to get, again, negative 1 to the power of 4 plus a times negative 1 squared plus b times negative 1 minus 2 equals neg 6. That's a neg 6. So therefore 1 plus a minus b minus 2 equals neg 6, which leads us to, in the corner, if I can squeeze it in, a minus b equals the first. So we've got 1 minus 2 is negative 1, so we're going to add 1, that's going to give you negative 5. So that's going to be the next equation, equation 2. So let me try and get the next slide up here and see how that works. Okay, so we've got a plus b equals 3 and a minus b equals... yes, I think we're okay. Okay, so a plus b equals 3 and a minus b equals -5. So there are our two equations. Okay, we're now looking at our simultaneous equations. We've obviously got a couple of options, first one being substitution, but given the way these equations are expressed in more of a factor form, so our coefficients and our variables on the left and our constants on the right, I would naturally choose the elimination method. So let me do equation 1 subtract equation 2, and thereby getting a, the a's will cancel out, so that'll go. The b subtract b will give me 2b, and the 3 minus 5 will give me an 8, so therefore b equals 4. I now have one of the coefficients that I need. I sub back in to get a, so let's go back into equation 1. So a plus b equals 3, but now we know b is actually 4, so therefore that means a is -1. So our two answers, again hopefully if we've done everything correctly, is a equals -1 and b equals 4.